Hello guys, in this video tutorial I would like to explain that how we can find minimum variance bound unbiased estimator, and then how to find their variance and how to find the lower bound of their variance. We will compare them as well. So let's see the first thing we will do that how to find this estimator and then their variance and lower bound. So I would like to write, let's go move to the video, the proper lecture. I would like to write that general form to find this MVBUE. Finding MVBUE. MVBUE, minimum variance bound unbiased estimator. If suppose you have a distribution, you need to take the likelihood function. Suppose we have sample x1 up to xn from a distribution that you can say f of x theta, then the MVBUE can be found in the following way. If we are able to express the first derivative of the log likelihood is equal to a t of x minus this one. So here this is that estimator for this function of parameter if we are able to express the log likelihood, the first derivative of log likelihood in this way, then this is that estimator, that is that unbiased estimator for this function of the parameter. This is not necessarily a function of parameter, this may be theta, only the parameter. So now let's have some example for this to explain this concept. Problem 1. Let x be a random sample from the following probability distribution. X be a random sample from the following probability distribution, from the following probability distribution, from the following probability distribution from the following probability distribution. That distribution you can write x theta, that is the function of the x and theta, that is theta, and to 1 plus x power theta power unto 1 plus theta, x greater than 0. Now the questions are, does there exist MVBUE for any function of theta? So this is the first question. This means that we need to express the first likelihood, the first derivative of the log likelihood in the above shape. If yes, the second question is if yes, then find its variance and compare it with the lower bound. Then find its variance and compare it with the lower bound. Okay, so there are two questions. The first one question is, does there exist MVBUE for any function of the parameter theta and the distribution is given, the density function is given? So this is the statement. And the second question is, if yes, then find its variance and compare it with the lower bound. So let's start. As we know that x has that distribution given, f of x theta is equal to theta n to 1 plus x power minus 1 plus theta, x greater than 0, then the likelihood, because we need to express the first derivative of the likelihood function in the above shape which we presented in the general theory introduction to the MVBUE. The log likelihood or the likelihood function for this distribution as, we will just denote this by L theta simply. That is equal to I from 1 to n, the multiplication of all distribution, and that is equal to, just need to multiply this n time, that is theta power n, and this is, you can say, in the multiplication from I1 to n to 1 plus xi power minus n to 1 plus theta. Now you can take the log, taking natural log on both sides, we get, and this will be simply, you can say, natural log theta power n product 1 plus xi power minus 1 plus theta, and this will be simply equal to natural log, this is equal to n natural log of theta plus, if you apply log on this product, this will become summation on, then this will become here from the power n to natural log of 1 plus xi. So this is the final expression, but we need to take derivative. Now this you can do little more things with this minus you can write here. So let's do one step more. That is equal to n natural log of theta minus 1 plus theta 1 plus xi. So you can see now this, now differentiating with respect to theta, now differentiate with respect to theta, we have the shape, this is equal to n divided by theta minus, and you can see this with this, you can take the derivative with respect to theta, so this is equal to summation 1 plus xi, log 1 plus xi, 1 plus xi. We need now to write this to make appropriate shape for this. Okay, you know the general form was this one, natural log of L a t of x minus some function of theta. So this you can make this, we should make parameter like here, so you can take minus common and of course n as well, so this is minus n, so this will become now summation 1 plus xi minus 1 divided by theta. You can see this look like the shape which we required. This look like the shape. So this is equal to this a t of x minus. So this is the same shape as we required, where a is equal to minus n, t is equal to, and remember that I took n common, so there should be n here in division. That is equal to 1 divided by n summation natural log of 1 plus xi, and this function of the parameter as theta power minus 1 r1 divided by theta. Therefore, so we can express successfully, therefore t of x, that is equal to 1 divided by n summation natural log of 1 plus xi as MVBUE for the function of theta, this one. So the one question is solved. We did this. Now variance of dx. Variance of dx. You can see that variance, you can calculate variance very easily by using, variance of t of x is equal to divided by a. So the variance is equal to this one. This means that take the first derivative of the function of the parameter and take square and divide by a. Simple. So this is equal to theta minus 1. So the first derivative of this is minus 1 divided by theta square, or you can say theta power minus 2, whatever, theta square, and a is minus, and you know already. So this means that minus 1 divided by theta square, you can take square of this. Oh, there is no square in this case. Remember, in this case there is no square. The square is in the other thing, the lower bound. Here is no square. So minus 1 theta square divided by n minus n, because a is equal to minus n. So this is equal to 1 divided by n theta square. Variance of t of x. So we calculated variance of t of x. Now the lower bound. Now the lower bound of the variance of t of x. Remember, the lower bound, you know that lower bound is equal to this is derivative square divided by minus expected value of like this. So you know that the first, okay, we know this already, we did this, but we don't know about this thing. So you need to do this. The first derivative of, we know that the first derivative of this likelihood function is equal to n divided by theta minus summation 1 plus xi. This means that the second derivative of this function will be equal to minus n divided by theta square. And of course, you can take the expectation. This is equal to expected value of minus n divided by theta square. So this again equal to minus n divided by theta square because these are constant. So now you can put these values in this formula. So the lower bound is equal to minus 1 divided by theta square whole square divided by minus n2 minus n divided by theta square. So this is equal to 1 divided by theta 4 divided by n divided by theta square, and that is equal to theta square divided by n theta 4, which is equal to 1 divided by n theta square, the lower bound. So in this case, for this distribution, variance of t of x is equal to lower bound of the variance for this estimator. Now thank you very much, and if you like the content of the channel, please subscribe the channel so that you can receive notification about the latest video. Again, thank you very much, and see you in the next video. Ciao.